Okay, good good day. Okay, I am Engineer Tolentino, and okay, I am from NU Manila, Philippines, and I'm now going to discuss the eighth part of the course of in differential equations. It's known as linear equation of order 1. Let me start by defining what is the linear equation of order 1. Now, the ODE dy dx plus yp of x equals p of x, where p of x and q of x are pure functions of x, is called the linear ODE of the first order. Now take a look at this DE. There should be only there should only be dy dx here in this element. There should be y here, and there should only be p of x and q of x here, which are pure functions of x. Now, let's start by deriving the formula, for this ODE, linear. Now, let us multiply both sides of this equation by dx. So, what we did is, we multiply both sides by dx here, and then, you get dy plus y p of x dx is p of x. Then transfer p of x to the left, and then factor dx. You have yp of x minus q of x, and then dx plus dy is 0. We want to find an integrating factor for this differential equation. So we let m be equal to yp of x minus q of x, and we let n is 1. Now getting partial derivatives, the partial derivative of m with respect to y is equal to p of x. Notice that p of x and q of x will be constants because you're differentiating partially with respect to y. Okay, at the same time, if you get the partial derivative of n with respect to x, the derivative of 1 is 0. And using our previous discussion for determination of integrating factors, we can use this formula 1 over n partial derivative of m with respect to y minus partial derivative of n with respect to x. Substitute 1 over 1, that is n, and then our partial derivative of m with respect to y is this, p of x, and then minus 0 gives you only p of x, which is a pure function of x. So an integrating factor is equal to e to the integral of p of x dx. Now instead of multiplying this by this equation here by e to the integral of p of x dx and solving the exact equivalent differential equation, we can start with this form. This is the original differential equation. Then we just differentiate y times the integrating factor. Okay, the derivative of y times e to the integral of p of x dx, this is a derivative of a product. This is y times e to the integral of p of x dx times the derivative of the integral of p of x dx is p of x plus e to the integral of p of x dx times the derivative of y is dy dx. Okay, note that e to the integral of p of x dx can be factored here, and you get dy dx plus yp of x. Okay, now observe that this form dy dx plus yp of x is similar to this one. What is the only missing element is the integrating factor. Okay, so if we multiply, let us multiply this equation, the left and right, by the integrating factor, which is e to the integral of p of x dx, and then the right side also by e to the integral of p of x dx. Now you see that this term here, is the same as this one there. So this can be replaced, by what? By y derivative with respect to x of y e to the integral of p of x dx, and the right side will be e to the integral of p of x dx p of x. So what happens is this becomes d dx of y e to the integral of p of x dx equals e to the integral of p of x dx ux. Transferring the dx, you get y e to the integral of p of x dx equals e to the integral of p of x dx p of x dx. And integrating both sides now gives you what? Gives you y e to the integral of p of x dx is integral of e to the integral of p of x dx p of x dx plus c. Now observe that in this equation, this term and this term, okay, is just an integrating factor. So this is an integrating factor. So let's have an example. Okay, let's solve. Alright, let's solve dy dx plus 3y over x is x cubed. Question, is it linear? Alright, this is the form. Okay, does it take the form, does the ODE takes the form dy dx plus y p of x is p of x? Obviously, you have what? You have dy dx there and dy dx there. You have y there, and then you have y there. And then, okay, these 3 over x and x cubed are what? Are p of x and p of x respectively. Therefore, this is linear. And, okay, now we conclude that p of x is 3 over x and p of x is x cubed. We get the integrating factor. The integrating factor is e to the integral of p of x dx, which is the same as e to the 3 over x dx, which is the same as e to the 3 ln of x, which is the same as e to the ln of x cubed, which is x cubed. Now, okay, always remember, because we will be dealing with this always, that e to the ln of u is u. So that is the rule of logarithm. So we'll remember this. Then what we do is we substitute it in what? We substitute it in this differential equation, rather in this solution. So you plug only y. Okay, you plug y and then x cubed. Okay, and then integral of, you put what? You put the integrating factor x cubed and then that p of x, p of x, which is x cubed dx plus c. The integral x cubed times x cubed is x to the 6, and the integral is x to the 7 over 7 plus c. Or you can solve for y. Y is x to the 4 over 7 plus c x to the negative 3. Okay. Let's have another example. X plus 1 dy dx minus 2y equals twice x plus 1. Now the question is this linear or not? Then let's simplify it first. Okay, this is the original differential equation. Okay, divide both sides by x plus 1. Okay, so you have to divide this by 1 over x plus 1. So what remains is dy dx minus 2y over x plus 1 is 2. Now, does it take the form dy dx plus y p of x is p of x? Okay, notice that you have dy dx there, dy dx there, you have y there, you have y there, and then the rest of the function, this is what? Negative 2 over x plus 1, and 2 represents what? Represents p of x and p of x respectively. Therefore, our p of x is negative 2 over x plus 1, and our p of x is 2. Our solution is, remember, you have to memorize this. The solution is y times integrating factor equals integrating factor times p of x dx. Get the integrating factor. E to the integral of p of x dx is e to this one, negative 2 over x plus 1 dx. That's the same as e to the negative 2 ln of x plus 1. That's the same as e to the ln of x plus 1 to the negative 2. That's the same as x plus 1 to the negative 2. So the integrating factor is x plus 1 to the negative 2. You have to what? You have to plug it there. So you have to plug it in this. Okay. So you have to plug the integrating factor in this equation. So you simply have y times the integrating factor is integral of 2 times the integrating factor dx plus c. Okay, simplify. The integral is, that is 2 times x plus 1 negative 1 over negative 1. That's negative 2 plus 1. Negative 1 over negative 1 plus c. And solving for y, this is just negative 2 times x plus 1 plus c times x plus 1 squared. Okay, this is our general solution. Okay, let's have example. Okay, now solve dx dy plus 2x is y. Question, is this linear? Okay, so alright, this will now take the form, will it take the form of dx dy plus x p of y is p of y. Alright, the roles of x and y here are reversed, but basically this is still a linear differential equation, but the linearity is in x. Okay, so is that taking the form? Alright, do you have a dx dy? Yes. Do you have an x? Do you have an x? Yes. And then you have a p of y there, that is 2 there. That is your p of y. And then your p of y, that is your what? That is your p of y. Therefore, the differential equation is linear in y. Okay, so next step is get your p of y. Okay, your p of y is 2 and p of y is y, and get the integrating factor. The integrating factor is e to the integral of p of y dy. That's the same as e to the 2 dy or e to the 2y. That's the integrating factor. Then our equation now is, look at how this equation is formed. This is x times the integrating factor is equal to the integral of the function y times the integrating factor dy plus c. Now this equation, rather this factor, alright, this term will involve integration by parts. Okay, so let's use a technique in order for us to determine integration by parts. Okay, this is the original function y and e to the 2y. What you do is differentiate until it becomes 0. The derivative of y is 1, the derivative of 1 with respect to y is 0. Integrate e to the 2y with respect to y, that is 1 half e to the 2y, and integrate it again, that's 1/4 e to the 2y. Now, for the integration, then this will be our integration. The signs will just be what? Alternating there. So our integration is what? Our integration is x e to the 2y, that is x e to the 2y, and then the integral is multiply that, that's y times 1 half e to the 2y, and then alternate. Okay, 1/4 e to the 2y, plug a negative sign there, plus c, and then solve for x. X is 1 half y minus 1/4 plus c e to the minus 2y. This is now our general solution. Okay, let's have example 4. Let's have again dx dy equals e to the y sine y minus x. Okay, question, is this linear? Okay, alright, does it take the form of, okay, does it take the form of dx dy again, dx dy plus what? Plus xp of y, xp of y equals p of y. Alright, so see, you have a dx dy there. Okay, you have an x there, and therefore your p of y is what? Your p of y is 1, so that is 1 there, and then you have your p of y there. Okay, so this therefore is a linear differential equation. Okay, the ODE takes the form dx dy plus x p of y is q of y. Okay, and then this is the general solution of, okay, xif equals integral of p of y if dy plus c. What is your if? Your if is e to the integral of p of y dy, and your p of y is 1. So what is your if? Okay, this is the same as, just what? E to the what? E to the, what is the integral of 1 dy? This is just y. So this is just y. That will be your integrating factor. So, okay, plug it there in this equation. You have what? You have x e to the y is integral of, this is your function p of y there, e to the y sine y, and this is your integrating factor dy plus c. Simplifying, you have x e to the y is integral of e to the y, e to the 2y sine y dy plus c. Now this will involve again integration by parts. Okay, a simpler way to solve this type of integral is, if you have e to the ay sine by dy, just compute 1 over a plus bi, assume it to be the same as c plus di, and the integral will just be equal to e to the ay times c sine bi plus d cosine bi. So in this case, we just have to, okay, we just have to compute 1 over 2 plus I. So multiply it by its conjugate, 1 times 2 minus I and 2 minus I there. So you have distribute 2 minus I over 4 minus I squared, that's negative 1. 2 minus I over 5, and then that's 2 over 5 minus 1 over 5I. So this means that this is your C there, and this is your D. Okay, so therefore in the integral, okay, you will have what? You will have to just attach that 2 over 5 and negative 1 over 5 in this equation there, where you have this a and b there. This is your 2 is your a and b is 1. Okay, so you have the equation x e to the y equals e to the 2y times 2 over 5 sine y minus 1 over 5 cosine y plus c. And dividing by e to the y, you will have the final solution, 2 over 5 e to the y sine y minus 1 over 5 e to the y cosine y plus c e to the minus y, okay, equal, okay, plus c e to the minus y. This will be your what? This will be your general solution.